Hello everyone, welcome back. I am Sai Krishna from Department of Aeronautical Engineering from the Institute of Aeronautical Engineering. Today we will be continuing our professional electric course, which is of CAE CAM, and continuing with that, we'll start with our next topic, which is of design process. Right? Under design process, what will be doing? We already covered this particular value. We'll elaborate it further under your next slides, which is of first under your design process is your problem identification. First, we are supposed while designing a new product, you are supposed to get what is the historical information that is being available on it, right? Let's say, for example, as previously considered, a water bottle, right? A bottle. Whenever you are designing a product such as bottle, what is the historical information that is available on it, right? For example, is there any use cases that has been made earlier? What kind of uses, what kind of material they have used? All this information, all the information such as this is available on your general sources. You can refer for books as well as other sources which give you the particular amount of information, right? Next, what will be the general solution that you can have basically in order to get the problem to be identified? If in the same case as water bottle, what is the issue that we are encountered? Basically, we are getting a point. We are getting a point where the fluid or the volume of particular fluid is to be carried from one point to another place in a feasible manner. So, in order to particularly carry out a feasible manner, what is the general solution that comes in your mind for an engineer's role? Basically, is firstly that should be taken care of in what position? A simple container having a liquid or a fluid, right? That usually is feasible to carry. Now, undergoing this, is there any specific requirement that the design is supposed to have, right? In order to have that particular part, we are having your next step is nothing but any required specification, right? In our case, if we are designing a particular volume of liquid, let's say for 1 liter, that will be a specification for a liquid, right? If instead of 1 liter, if you are going for 1.5 also, that will be also another specification that you are giving. Next, along with the volume of the fluid or volume of the liquid that you want to contain, additionally, what is the amount of height, right? What is the amount of height of the container that you are planning to have, right? What is the width or what is the thickness? All these are your specifications related to your geometric model and what is the related to your problem identification. And last is nothing but your market forces. Market forces are nothing but whatever there is a demand in your market. Let's say you are creating a new water bottle, but it has few older versions. For example, let's say for Coca-Cola, right? The Coca-Cola has many versions of its bottle. Earlier they were glass bottles. Now you are having PET bottles, right? Now, what does the market forces contribute actually, to be precise? For market forces, let's say there is a economy, right? There is a cost associated with manufacturing glass bottles, whereas the different costs associated with PET bottles. Whereas glass bottles under transit and all, they tend to fail, right? Which is a huge loss for them. Whereas for PET, easy to carry, easy to hold, and easy to transfer, right? In all these cases, next, what will be the demand that the consumer will have majorly is the feasibility in carrying the particular liquid, in this case Coca-Cola, right? How well the person will be able to carry out or take care his feasible conditions for carrying PET bottle or PET bottle for using a drink. In the same case, all these things, right, in a similar way, all these things will go for your problem identification and need. Next, how do you define a problem basically? Which is your next step under your design process is first is your preliminary design, right? A simple long column with some opening is supposed to carry 1 liter of liquid as we have defined earlier is your water bottle, right? And what will your next is your preliminary skills. How it is supposed to look. If you are having any branding, how you are supposed to be implementing the same, right? And the second last is your brainstorming. Brainstorming in a way that how well it is flexible to be used. You are supposed to be considering all the factors that include considering all the realistic market appliances or market applications from the consumer end as well as from the manufacturer's perspective. And the last is nothing but your designer's evaluation of your designs. How well you will evaluate the designs, right? While while solving a problem, you will be having multiple number of designs. Let's say 1, 2, 3, 4, right? All 4 divisions will be having a number of uh, processes or a number of divisions for which a number of designs you will be having. But brainstorming the conditions or realistic conditions on which these individual designs will perform will let you know how well a design is suitable for your current market situation, right? All these things you will be doing in terms of defining a problem, right? As you define, you also will be able to conceptualize how well it will be able to act. Now coming for next is your geometric model. Under geometric model, what you will be doing is basically you will be creating a 3D model, right? A 3D model either in one of the CAD softwares or any of the supporting softwares in order to generate to look how it will be looking, how it will be performing as well as looking. Now in this, as earlier discussed, we will be we will be evaluating a certain amount of designs and we will be creating a geometry for the same, right? On the same, we are supposed to compare each one another in such a way that how well it is being evaluated. Next, visualization. Whatever the model we are doing, either we are creating a number of 3D terms to visualize it further, right? To visualize the same in terms of what? In terms of graphics. Graphics, particularly your computer graphics. Computers, as assisted, will help us the designers to visually see how well the object looks under your original or real-time scenario. Same thing, if you want, you can just redo and change the scenario in your computer software to get the scenario required. Now, the last is your preliminary analysis. How well the object will be able to perform according to your modeling dimensions that you are having. This thing you are supposed to have a clear idea while designing, right? Next, we will be going for engineering analysis, where you will be analyzing a particular body or a product under different terms. First, we will call it as statics, kinematics. Let us understand statics. Whenever an object is independent of its time relative and it's stable, I mean it's under equilibrium, then you will be going for static analysis. Basically, for example, a bottle, right? A bottle which is stationary here and it's having some liquid, right? So, what are the forces acting on it if you are applying a certain amount of load? What is a certain amount of load on other sides, right? All these things you will be understanding the equilibrium irrespective of the time that it happens. Whereas for kinematics, whenever the same bottle is under motion, let's say in transport, what will be the effect of the fluid onto the wall or on wall onto the fluid, vice versa, right? In those both cases, we will be doing this. Next, we will be doing for design for an assembly. For example, for a car is a product which is made up of multiple sub-assemblies, and each assembly is made up of multiple of parts or components, right? Whenever we are designing a certain product at the end, right, irrespective of the type of product, whatever the assemblies that we are supposed to perform in order to get my original product out, those while designing itself we are supposed to consider them as collectively together. For example, let's say a simple bolt. a bolt in a car, right? Same bolt will be pushed on or designed in such a way that it is easily arrangeable or assembled in your cars. The same thing, let's say for any other screw or washer, right? All these are few common components which you will be using for creation for a larger assembly. And while designing these similar small components, you will be making sure that these are made accordance or designed accordance for the assembly point of view. Next, in the same way, you will be designing in terms of manufacturing point of view. How is basically, if you are considering the same example such as you bolt as well as screw, these are manufactured in a way, these are designed in such a way that these are eased in manufacture for your better productivity skills. Let's say for simple car, same example, the car, whenever you are designing, you are supposed to design it for assemble as well as manufacture. Assembly point of view is respect to whatever the sub components you are taking, they are getting them together. Now manufacturer's point of view is how well or how ease in manufacturing the whole component further. Now at the next, at last, under engineering as well as analysis and optimization, we will be doing a heat or flow analysis. For example, simple heat sink of a CPU, simple fins of a CPU, right? What you will be doing in this basically, right? Let's consider this as CPU as a product. First, you will be performing static analysis, calibrating analysis, which includes what is the equilibrium that a CPU sink heat sink can attain. Then you will be using a kinematic analysis, performing on what is the effect of the motion or what is the effect of the body on it. Next, what you will be doing what is basically you will be performing a heat or flow analysis because that is the primary function as discussed earlier. As discussed earlier, first you're identifying the need, right? Your need of your CPU fan is for getting the heat out, right? The same heat, whatever you are getting, is get thrown out. So, in order to know how effectively it is able to manage the heat through the whole system or how in the whole CPU, you will performing a heat analysis or a flow analysis, which contributes to your understanding how the CPU fan works, right? And next is nothing but your prototype development. Now, developing a model physically in terms to understand how it will be working, how it will be creating on a smaller scale is nothing but a prototype. What you will be doing under prototype is basically you will be geometrically modeling, evaluation as well as visualization and preliminary analysis. All these things you will be performing to get your prototype out. In other cases, what we can say is you will be having a geometric model, right? You will be expressing the materials, right? The materials that you can able to use to produce a final product. You can test out new materials. You can see how well the manufacturing process works, and the last, and how well you can test the same prototype for how well it will be working, right? In same physical conditions in real time. Next, how you are developing a management process, right? First is nothing but a process plan. For example, as we have considered earlier, simple car will be having different processes in order to manufacture a complete car, right? So in order to manufacture a complete car, what you'll be doing, you'll be having all the sub-components or sub-assemblies ready, right? And each sub-assembly will be having separate parts or components, right? All these are gathered back onto a single assembly line, and we'll be planning accordingly according to the time that is taking place for better productivity. So let's say for example, line first, whenever we are having in the same example what we are considering as car, what we'll be doing is basically we will be creating a few stations we'll be generating a few stations on which, and first we'll be assembling a chassis, then doors, next axles, next engine, next interior, next windshield, so on to get your final product as car, right? So these will be your all the sub process that you will be taking care in order to get your final product, which is a car. So in order to get the final product, what are the steps, right? What are the, it can be manufacturing steps or other manufacturing assisted steps. What are the process you are generating, steps you are generating or planning according to the time taken or in accordance to everything else, that is called as the process planning, right? Either it can be manufacturing process, it can be quality control process, anything. Next is nothing but your tool design, right? If the same car, whatever we are discussing till now, is of newer design, right? Newer design. At the time, what you are supposed to have a new tool for creation of all the stamps or all the sheet metal parts that it is required. So, in order to create your new car, you are supposed to create a new tool design, right? If it's an older one, then you can able to recycle or reuse the same tool design. But for every change in design, what you'll be doing, you'll be changing the new and creation of new tool design, which again will enhance the same manufacturing process development. Next is your manufacturing information generation. What does the manufacturing information generation mean? Basically, whenever in order to undergo a machine process, let's say I want to manufacture a part which looks like this. Right? It's a simple part. Let's say we are using it in a car. We want to produce the same part in mass batches by using some computer assisted manufacturing techniques. For that, what is the information that it needed? Whatever you are generating is your manufacturing information generation. How? Let's say the same thing is to be carved out of a billet of some diameter, right? What kind of machining processes? What is the speeds? What is the speed rates? Everything that is relevant to in order to get your final product out. In this case, your part is your manufacturing information generation. This can consist of your basic CNC course or basic manufacturing process that are instructions that are required or to be understood by a computer or else a manufacturer or the production worker to get your final product out. Next is your manufacturing simulation. As soon as you get your product out, sorry, not before getting product out, as soon as you get your process done, tool design done, and getting the information ready, you are supposed to simulate or get a small dry run, how well the manufacturing process will be working, right? Although you are creating a new process, you are developing a new process, you are supposed to simulate the same to get your exact value or exact product out in order to understand it further. If some design changes are required, you can implement them based on the timing that each manufacturing part takes. Next is the information requirement design, right? Now in this, what we will be doing is basically according to the information, right? According to the information that a manufacturer generates, based on that you will be designing. And second last is your time as well as motion study. In this case, in the same example as car, what is the time taken to join a chassis? What is the time taken to join your doors? What is the time taken to join your axles? What is the time taken to install your engine? Right? Whatever the time that it is taking individually to complete a whole product, it can be assembled or manufacturing process, that as well as how well the movement occurs in between the stations to get your final product out. All this you are studying according to your type of manufacturing process that you will be producing. And the last is nothing but your production plan design. Although you are having a newer product, in order to get your product out in real life, you are supposed to create a small process line which consists of all the manufacturing operations that you have planned earlier, right? Whatever you have planned earlier, according to this, you are supposed to get your plan design. That plan design is basically you are creating a new, right? Because if it's a newer car, you are supposed to have a newer plan design to get your product in. So all this will relate to your manufacturing process development. Now, under this, one more thing that we are supposed to discuss, we will be discussing is computer assisted product life cycle. Under this, what we will be doing, let's say for example, any manufacturer, let's say if I am a manufacturer, what I can do basically is I can see a need of a product, right? A need of the product which I can forecast that the particular amount of product is necessary during a particular period of time, because there is a shortage earlier year, so I can see there is a requirement for a particular product. So according to that, I can conceptualize my product, right? I can conceptualize my product to understand how well the product should be able to satisfy or suitable or satisfy the needs that are required. Next, according to that, what I will be doing is I will be designing, right? Designing a product in accordance to my using my computers. For that, what I am supposed to take is basically I will consider my geometrical modeling, or I will do my geometrical modeling and perform a small finite element analysis to understand how the object works, how it will be performing. Now, the same product will be simulated, right? Because I am supposed to know how my design is being validated. So according to that, I am supposed to create this product simulation to understand how it will be affecting under my real time digitally. So this again, if it is all good, I mean the product has been withheld all the tests and the analysis is good, what are the results is well satisfied within the range of your standards, then you will be sending it for drafting. Drafting is nothing but a simple 2D document which consists of all the product dimensional data, geometrical data, and gives you the manufacturer's ability to read how well to manufacture a particular product to get its final product out. According to the designer's requirement, it is a small equivalent document which covers the manufacturer's perspective of manufacturing. Now, all this process, particularly CAD, simulation, FEA as well as geometric modeling, will be coming under CAD, which stands for Computer Aided Design, right? All the process which include geometric modeling, designing, simulation as well as drafting, right? All these components will be included under a single cycle or a single subsection of a cycle called computer aided design. Now coming for next, as soon as your design is ready, what you will be doing is basically you will be planning a process, how well the product is supposed to be done. For that, what you are doing, you are ordering a new equipment, because if it's a new product, you need new equipment for manufacturing. You are creating a new product life cycle. According to that, you will be ordering a newer life cycle, your equipment. Now the same equipment will be again put into use into your actual production. Next, what you will be doing, you will be planning the amount of material that is required, right? According to the number of products that you are manufacturing, the material planning is also necessary in order to get the exact value of material that is required to you. If you are storing your excess material, it's a loss. If you are storing less material, it's also again a loss for you. So in order to overcome those, what you will be doing, you will be planning the requirement of material, and accordingly you will be putting it back to your actual production cycle, right? Next, you will be using computer-aided CNC part programs, right? In order to manufacture any part, what you will be doing is basically you will be generating a computer program part, also called as for CNCs. Those will help you to run machines, particularly numeric control, your lathe as well as mill. Not only those, every other machine, numeric controlled machine, to perform certain manufacturing actions precisely, right? That will include the codes which are being sent to your CNC machines, which are again put back to your final actual production. Next, what you'll be doing, you'll be scheduling, computer scheduling. You'll be scheduling according to the time taken by the machine for performing or for creating a particular type of operation in every case, right? Next, computer aided work standards. According to the work standards, what you will be doing, you will be creating the manufacturers, you will be planning accordingly by including the standards that a person or a machine is supposed to work. For example, in India or in general, 8 hours per day is the standard work life of any of the individual. So if you are exceeding that, at that time you are liable to maintain or you are liable to penalize. So in order to not to go that side, what you will be doing, basically you will be, according to standards, you are scheduling or you are planning accordingly. Next, computer aided tool design, right? Whatever the tools required, whatever the tool required for in order to create your product, in that tool you are designing as new, right? Your product requires new tool, which again you are trying out, because every tool is not exactly to be precise. So as soon as a simple prototype of a tool has been made, you will be trying it out to manufacture a small piece. So let's to check out that, yeah, does the tool really work or not. After all this, this all data whatever we discussed is again put back to your actual production, right? In this, what I actually miss this robots, that is also as a part of your computer aided scheduling, which controls you're scheduling your robots to perform certain type of action during certain amount of time, right? As the production goes on, you will be getting a new product during newer product right from your factory or production plant, right? Whatever the product you are getting out of your plant, you are supposed to be quality inspection. What is the quality inspection means? Basically, does the product is getting out according to your required specifications, right? According to the designer specifications that you are supposed to check. For example, what we have taken earlier is simple car, right? A car will undergo quality inspection to check the color, finish, the drive quality, all mother, right? All these things are few parameters, quality parameters on which a car is supposed to be checked before final delivery, right? All these things, quality checks are supposed will be happening right after the production of a particular product to verify that it is in meeting requirements or meeting the standards that it is specified to do. And at the last, as the product has been arrived, it is supposed to be going under marketing, right? Or the markets. What does the market do? Market is nothing but it brings the product to consumer, right? Product to the consumer. That happens as the part of marketing. Marketing will let the product reach the customers as on when required, based on the demand as well as supply. At the last, what you will be having is your feedback. Now, the customer feedback is dependent on the type of product you'll be sending. If in few cases the customer might not be able to like a product based on its type of material or type of function, that is it is not the percentage of function that is not able to perform clearly, or the type of feedback depends on the customer also, right? If the improper use of the product, all the feedbacks are again sent back to your product concept for the designers in order to get a clear visualization or clear idea that how well the product will be performing, right? Now in this, what I missed is basically CAM. CAM stands for computer aided manufacturing, right? With the help of computers, you are aiding either in terms of directly production or indirectly processing or scheduling. You are using computers to get your product out, also called as your CAM. Now, All the whole product life cycle is used accordingly with the use of computers integratedly called as SIM. SIM stands for Computer Integrated Manufacturing, right? Where computers are integrated in the field of design as well as manufacturing. So under product life cycle, you can see few more things. In other words, CAD plus CAM both combinedly form computer integrated manufacturing, right? First, we'll elaborate ourselves with the CAD. CAD, computer design, thus utilizes the computer as a tool for all the functions that are involved in the design process. And the main function, which also includes, is layout design, how well the product lies in a complete assembly, and individual component modeling, model a component individually irrespective of dependency on others. But as a CAD also, it provides you a better knowledge, better connectivity for individual components to see how well they are stacking together or how well they will be together. Next is your assembly modeling, how well the multiple components are assembled and how well they can be assembled together, and any interference or any tolerances that are available, that are being bought during that. And the last is your engineering drawings, right? Engineering drawings are the simple tool drawing I discussed earlier, also called as draft, right? This helps the manufacturers to view how well it will be performing during manufacturing. Next is your computer manufacturing, in which you will be having three particular steps. First, industrial manufacturing are broadly classified under three sections, which is mass production, batch production, as well as jobs of production. During this, mass production is particularly means of creating any product in large lots. For example, a simple pen, ballpoint pen. A ballpoint pen is being manufactured as mass production because, irrespective of the shape, irrespective of others, what you'll be doing, you'll be mass producing the same. Next, as a part of your batch production, medium size lots. Example, industry machines. Other examples are ACs, or any other examples are aircraft. Aircrafts, for example, we will be having number of models, number of machines to work on. So for that, we are producing under batch. And at last is your jobs of production. Very small lots, or as soon as a few of batch is required. For example, smaller aircraft, which require, let's say for example, small passenger aircraft or small system training aircraft, which are made according to the order, as they are not that much used for current generation or 21st century. So those particular amount of aircraft will be used or produced according to the job or according to the order that is required, which is nothing but your small lots in a quantity of 5, 10, somewhere around. But in your batch production, if let's say for Airbus A320, A320 is one of the recent aircrafts. For that, if an order is being made, for that they can use a batch production because batch of A320s can be made. Other example for batch production is your pharmaceutical medicines. Right? Pharmaceutical medicines are also made under batch production. Not only pharmaceutical medicines, other your eatables, particularly to be seen as your FMCG goods, are also produced under batch production. Next, your manufacturing methods. This will tell you how well or how many, according to the variety and the rate of volume, how well the productivity or flexibility changes. First, this simple graph, which is putting us under x-axis, you will be having type of variety or a variety of product that are available, and in the y-axis, you will be having a volume of product that is being manufactured. In both the axes, you will be having three sections: first, low, medium, as well as high. Now, in this, if you are going for low to low, right, low volume with a low variety, what is the area that it lies? Basically, is not feasible, right? Medium variety with low quantity will be coming under flexible manufacturing system somewhat, but not that much flexible. Whereas for higher number of variety but lower production rates or lower volume will be coming along the standalone CNCs, or let's say you are having one CNC. A simple CNC will able to store number of programs within which it is able to perform a number of variety of products accordingly, right? That will be a standalone CNC. Next, we'll go for low with medium volume, right? Low with medium volume. At that time, you are supposed to create a specified dedicated system, right? A specified dedicated system which is supposed to be working for a medium quantity of goods with small variety. Next, as the medium to medium, right? Medium variety of goods with medium variety of volume. For those, you will be getting a simple flexible manufacturing system because you are able to change the limited amount of varieties in accordance to the limited amount of volume that a product is needed. Similarly, high number of variety with medium number of volume, right? High number of variety with medium number of volume is very less opted because those can't be able to manufacture in a single standalone CNC or any other part. Now coming for your high volume with low variety is one of your examples for your mass manufacturing, right? Let's say for mass manufacturing of pens, what happens is basically you'll be having low variety, or let's say a few colors, one or two colors, then you'll be manufacturing the same ballpoint pens for higher volumes. Similarly, medium variety will also be not there. I mean, medium variety for high production rate will also cost you more. Similarly, for high as well as high will also cost you more. Now, in this case, as you can see, or what we can observe basically is, as the variety increases, right? As the variety increases from the consumer point of view, right? As the variety increases, the consumer point of view, he's flexible, right? He's flexible to choose number of varieties as well as the manufacturer's perspective. He is less flexible to manufacture mass production. For example, whatever we have discussed earlier, which is batch, mass, job shop. All three manufacturing processes. Considering this, there is a reduction in flexibility as the volume decreases and the variety increases. Now coming to the same, the productivity increases as the variety decreases. Volume as well as variety decreases. In this case, same thing. In your mass manufacturing methods, what you'll be having high volumes and low varieties. In your job shop production, what you'll be having basically low volumes, high variety. So this case is basically for increased in productivity, right? Increase in productivity. Now, another case, coming to flexibility, mass, you will be having it is the same, which is high volume, low variety. Job shop is low volume, high variety. The productivity increases as it goes towards the mass production, and flexibility decreases as it goes towards mass, whereas the flexibility increases as you are changing from your mass production methods or mass manufacturing product to your job shop production methods. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.